All right, now we have very hard to read directions. So it just says, find the circumference of each circle. Leave your answers in terms of pi. Remember, pi has no end. It starts, it's like 3.14159232384 and if you remember in my classroom on top of my like document camera desk, you know, podium that I use, I have a poster and I think it has over 2,000 places after the decimal. There is no end. So here's my question. How many decimal places do you use afterwards? 2, 3, 1,000, 2,000? Well, it doesn't have an end. It's a God number. It's an infinite number. In some, not infinite number, how do you say it? Transcendental number is the right word to say because it goes without an end. They can't find an end. So how far do I go as approximate? Well, I don't know. So instead, we're just going to use that symbol for pi instead. It's kind of like not putting decimals in for radicals. So you're going to get used to having in terms of pi. So when they see things, leave in terms of pi. Make sure you have a pi symbol there. Or if they give you a decimal, use your pi key on your calculator. Do not use 3.14. Use your pi key on there. It'll be more exact. So the first one is, they go, the diameter is 30 centimeters. So my circumference, I know the formula is pi times diameter. So now, just like area, I plug it in. Pi times 30. I just rewrite it as 30 times pi centimeters. Circumference is linear. Circumference is linear, okay? So that means not being squared like area. So we still are going to label it very carefully. Now, when they give us the radius, it's really easy to make sure we get this right. The circumference is 2 pi times the radius. So I plug in and I get 2 pi times 6. I can't multiply these pi times 6, so I have to go the two numbers together. That's going to be 12 pi centimeters. Yes, you can get, make sure you get the pi there, fractions and stuff too, because look at this next one. The diameter is 5/2 meters. Well, your circumference is pi times diameter, so I'm going to go pi times 5/2. Where do we put the pi? Well, the pi goes over 1. Then you go numerators across, denominators across. 5 pi over 2 meters. There's your circumference. And that's your, notice it's not in degrees. This is like your linear distance around. So like when you have a circle, instead of having 90 degrees here, you're going to have a physical measurement. Like in inches or feet, you know, something like that. You can find it. Now, we're going to find what lengths of arcs. Now, we know arcs are in degree measure, but they're also in physical length. So remember the following. The length of an arc is just the fraction of the circumference of a circle. So what we're going to do is we're going to make a formula for this. So let's figure out, first of all, arc length. What does that mean in its definition? Arc length is the distance along an arc measured in linear units. So that's like in inches, centimeters, you know, linear units, inches, meters, centimeters, etc. Okay? So I'm going to find it. Now, here's a few things we need to know. First of all, in order to do this, you have to know your radius. M is degree measure of the arc. Okay, so we're going to use that. In fact, we're going to change this capital L to a cursive lowercase l, and we're going to use this. Remember, it's a fraction of the circumference. So we are going to write it as the following. M over 360 degrees. That gets me my fraction, because all the way around a circle is 360. So if I use up the degree measurements, it gives me that, times my circumference. So we're going to always go, let's go 2 pi r here. Okay? For some of you, you could go m over 360 times c, which is circumference, as long as you remember what circumference is. Now, the biggest thing with finding length of the arc is plugging stuff in carefully and working with fractions, but also making sure you're getting the right arc. So I'm going to highlight the arcs, and I would actually redraw and highlight the arcs on your homework. It would actually help you. First one, I want to know the arc AB. So that actually means just this arc right here. Okay? Now when I have that, remember my formula. It's this one right here is what we're going to use, okay? The length is the degree measure over 360 times my circumference, which is 2 pi r. Well, that means I need to know the radius. Well, if the diameter is 24, this is 12. So I can use the fact that I'd have a 12 there. My degree measure is 90 degrees because it's the same as my central angle. So now I just plug it in. 90 over 360. My radius is 12, so I get 2 pi times 12. Okay? So now this reduces down to 1/4 times, what's 2 times 12? 24 pi. So I get my pi comes along 24 pi. That's over 1. So now let's multiply it together. 24 pi over 4 is 6 pi. And now this is linear measurement, so it's 6 pi inches. There's the length of this arc. So 6 times 3.14, roughly, we're going to be a little over 18, almost 19 inches. All right, now we're going to do the next one. I want to find the measure of, or the arc length of arc CDE. So I start at C, I go to D, I end where? At E. I'm going this way this time. Notice not arc CE, the sweet little one that's 40 degrees. How do I find the degree measure of arc CDE? Well, the degree measure of arc CDE is just going to be 360 minus 40. It's going to be 320 degrees. So right on. Then I can use my length formula for the arc. It's m over 360 times my circumference, which is 2 pi r. So m over 360, which is going to be 320 over 360, is 2 pi, my radius is 9. So what do we get here? 320 over 360 actually reduces down to 8 over 9. 9 times 2 is 18 pi. And we're going to put that over 1. Okay? Now, when I multiply this together, I get 8 times 18. It's 144 pi. All right? All over 9. Now, 144 can be divisible by 9. In fact, it's 16, so that'd be 16 pi centimeters. All right? Now, another way you could have done this quicker, actually, would have been like, oh, 9 can go into 18 2 times. 8 times 2 is 16 pi centimeters. Not too bad. All right, last but not least, I'm looking for arc FH. So I need a minor arc. So the minor arc means we're going to go this way this time, not the other way when we're working with it. Remember, we have to have the radius and we have to have degree measure of our arc. Well, what's the degree measure of our arc? I'm going to use arc addition postulate. Sum of the parts equal the whole. 90 plus 45 is 135 degrees. So radius, 3 meters. I think I got this down. Length of the arc is m over 360 times 2 pi r. M is 135 degrees over 360. 2 pi, my radius is 3. So I then get 135 over 360 times 6 pi. Now, here's the cool thing. Over 1. I can actually reduce this now working with this because you can cross-reduce when you're multiplying them together. I know 6 can go in there 60 times, and then I can go, okay, what is 135 over 60? What can go into both? Well, I know 5 can go into both. I think I can go a little bit more. I think I can almost go 15 in for each, and it actually reduced down to 9 pi over 4, and they told us meters here, so that's going to be in meters. So the length of the arc is 9 pi over 4 meters. Because it said leave our answers in terms of pi, I can't have any decimals. hopefully that helps get you guys started on this. I know you might have some questions, but I think you'll do a great job.